Okay, I think we should be live. Everything looks good on my end, though YouTube just earlier set me up with a copyright claim for some reason, even though I was just trying to test it as an unlisted stream. So let's hope that does not happen again. But welcome to our presentation on Azure Pipelines YAML, as you can see on the screen. I wanted to talk about this mainly because it seems that whenever anybody is talking about Azure DevOps in a larger presentation, they are always using the classical graphic UI to create their pipelines and so on. And while that is a good way to show things, I think the right way to do your pipelines is with YAML instead of the classic ones. If you have any questions during the presentation, please type them in on the YouTube chat, and I will take a look at them at the end of the presentation. So let's begin. First of all, a little bit about myself. So my name is Pasi Huuhka. I work as a DevOps architect at Azure. And I've been working on Azure since, let's say, 2014, even though most of the stuff that we were doing back then were quite simple. And some of those services don't even exist any longer. And during this time, I've helped to develop and automate applications for over 20 companies, probably closing 30 right now. You can find me on Twitter, and I also blog almost weekly or bi-weekly, depending a little bit on the time. And I'm also an active participant and an organizer in the Finland Azure user group community. And I also have some Azure certifications, and I'm also an MCT. And who is Azure then? Well, basically we do Azure PaaS. And we have been doing that since 2011, 100%. And as you can see, we have a lot of experienced people in the company as well, and some Azure MVPs and Microsoft partnerships and whatever. And this year, we also were able to go to Belgium as well. So we have a second office now. So one could say that we are now an international company. So about the session then. First of all, you will learn how Azure Pipelines function and how YAML pipelines improve on the classic approach. You will then also get to know the benefits of pipelines as code and kind of understand how to take advantage of them. We'll also take a look at how Azure Pipelines YAML helps you control your deployments and also the deployments on your whole Azure DevOps organization. And then we have some best practices and demos and whatnot at the end. So let's begin with some pipeline basics to get everyone up to speed. So basically, if you have not used Azure DevOps before, it's a combination of these 5 services. So first of all, you have Azure Boards, which is kind of a Jira competitor. You have work item tracking and statuses there. Then you have your private repositories as Azure Repos. Then the star of the show today, Azure Pipelines, which are a CI/CD tool. And then you have Azure Test Plans, which is kind of a manual testing, test management suite. And then Azure Artifacts, which allows you to do NuGet package feeds, and it's kind of an underlying service, transferring packages from pipelines to others. Then a little bit about Azure Pipelines themselves. Basically, they support any language and any platform, of course. Under the hood, they're just kind of VMs running your pipeline logic. Then Kubernetes, of course, also supported. And they are also very extensible, as there's a huge marketplace full of custom and ready-made tasks for you to use. They also provide the capability to deploy to any cloud because, well, even though there's Azure in the name, you can do whatever you want with them. And you get a lot of stuff for free, even if you're not doing open source. But I think everything almost is free if you are doing open source. And they also have some advanced features like release gates and, in this sense, YAML pipelines as well. So, about pipeline concepts then. First of all, you of course have your repositories. Your code lives there. You need to build that code, so you have a build pipeline. And a build pipeline does these things. It gets the source code, first of all. It installs some tools that are needed. It builds your solution, runs some tests against it, and then packages, publishes, and so on. Then those packages are moved through Azure artifacts to your release pipeline. And why you would have two of these is, of course, that you might run a lot more builds that might not pass your tests, and you wouldn't want to release those. So you don't need to have a single pipeline doing the whole build and release structuring. But the release pipeline, anyway, has these kinds of tasks. So, as the name says, it kind of releases to environments in different stages. And it can check approvals and gates in between. So does your test environment actually work? Can we go to production and so on? And then you can update environment statuses and work item statuses to Azure boards and also I think to Jira. And then in the end you have your application environments where all the packages then go. Pipelines have a structure behind them. And the first big part in a pipeline is a stage. So stage can be something like building a package or running these tests or deploying to production, for example. And these are kind of the same thing that the classic release pipelines are divided into if you have ever worked with those. Each of these stages can contain one to many jobs. And jobs can be something like deploying the backend, deploying the front end, and so on. In a sense, a job is kind of a unit of work that gets set to one of the VMs in your agent pool that run the deployment logic behind the scenes. And with both jobs and stages, you're actually able to create these kind of dependency graphs. So you can say that job 1 is dependent on job 2, or these can run in parallel. And there are a couple of different types of jobs that you can do, which we will take on later on. But the more advanced types are only available to YAML. Then you of course need to do some work on your pipeline inside the jobs themselves. So basically there are steps, and these are kind of linear queues or combinations of different functionality. They could be something like downloading the artifacts that we provided in the build pipeline, running a deployment script, and maybe running integration tests or end-to-end tests against the environment. And one thing to notice that not all of these are necessarily required for all of your pipelines. For example, build pipeline can just be one job. So let's take a look at the classic pipelines first. So here we have the kind of status view of a pipeline. You can see that we have the stages here in my pipeline. And if we take a look at what's inside here, actually, I just have a simple pipeline with dev, test, QA, and production. We are basically using a Microsoft release flow branching strategy. So stuff from master goes to dev and test, and then stuff from release branches go to QA and production. And here are the first issues that come with using classical pipelines. So I have 4 stages. If I need to do a change to all of them, I kind of need to do the change 4 times then. If I change something here, in this case, well, it doesn't change on the other ones. So we have quite a lot of repeated work. This also means that if I need to do a change to test, I cannot do it to production at the same time necessarily, because the other branch might not have the required binaries that are needed for that step to actually go through correctly. So you kind of need to time your changes very carefully. And this also leads us to the issue that, okay, if I change this dev, well, it breaks the pipeline for everyone else. I could do a clone of this pipeline, test my changes in that one, and then make the changes here in the dev when I know that everything is working. But that, in the end, leads to duplicate work again. And also, if I make a change here, let's change this name, for example, I can just save it, and without any comments, now the change is there. There's nobody that can approve this change. I can do whatever I want here, in this case. And the last issue here is that we have these jobs deploying ARM backend and frontend. There is no way to say in the classic world that deploy backend and deploy frontend both rely on deploying ARM job. So these cannot run in parallel in this case. One way to get around this with the classic pipelines is if you are using the stages instead of those jobs, basically. So here I have an example of dev backend and dev frontend. So these can run in parallel, of course. But it leads to quite a messy status view here, as you can see. So back to the presentation then. Let's check that everything looks correct here. Yeah. So back to our problems. We had a lot of repeated work, first of all. Timing changes was also quite hard. We had no great ability to test things before actually doing the changes and breaking things for everyone else. Also, the parallelization aspect did require some compromises in other aspects. And we had no capability to approve changes. Thankfully, YAML is here, and as it happens, it kind of fixes all of these issues for us. But what actually is YAML? Well, in a nutshell, it's kind of just the pipeline definition using yet another markup language. And that's kind of the one where spacing matters. And that can be a good thing or a bad thing, depending on who you ask. But most of the modern pipeline tools use YAML at the moment. More importantly, though, it is kind of Azure DevOps' implementation of pipelines as code. It was initially in public preview at the end of 2017. And most of the new features actually come to YAML first. And some might not be implemented to the classic pipelines at all. Who knows? And here's an example of a YAML pipeline. So as I showed you earlier, we have stages 1 and 2. Stages have jobs inside them, and jobs have steps inside them. Here I have just some tasks. So NuGet commands, for example. Perhaps I should show this a little bit longer here. All right. So pipelines as code then. What is that? Martin Fowler has said that infrastructure as code is the approach to defining computing and network infrastructure through source code, just like any other software system. So, in a sense, Pipelines as code is kind of similar, but you just define your continuous integration and deployment through source code. And this has many benefits that we will take a look at soon. This is not really a new thing, considering that cruise control, which was the first CI server in 2000, was based on something that could be called pipelines as code. So it has kind of taken us 20 years to really get there. So the benefits then. Well, first of all, we have additional version control. And this is pretty much the biggest thing there is. Because, well, your team is probably already using Git for your source code, so they know all the processes, and all of the processes that they have transfer directly to pipelines as code and infrastructure as code. We also get the ability to run automated tests against our code. And we get less stress from rolling out changes and reduced recovery time as well. If you make it so, your logic can also be self-documenting, and as everything is in code, it can be easily reused. From the YAML or the pipeline perspective then, let's take a closer look at these benefits. So addition of version control really gets you faster and more controlled development flow. Basically anyone can create their own branch, make changes to a pipeline, and run it without hurting anyone else. And this also allows you to use a pull request process. So basically you get the testing and verification of changes right there. Another good thing is that your code and pipeline logic stays in sync, along with your infrastructure as code as well. So this means that, let's say that you have a deployment that was done a month ago, and you need to go back to it for whatever reason. You can be sure that the whole package works when you go back to that time in the branch or in your Git repository, because everything was in sync at that point. If you're working with Classic, well, then you would need to go back a month and try to figure out what was your deployment logic like back then. And that is not always easy. And this also leads us to having portability of the whole product. So everything ships in the same package. Let's say that you are working on an open source project and you want to make it easy for new developer to get going. So they can just pretty much fork your repository, add the pipelines, and they are ready to go. They have their own environment set up in minutes or hours. So the second big thing, code reuse. So YAML supports templates and parameters. And it also enables you to do standardized company pipelines through these things called repositories as resources. And this leads to the ability to create separation of concerns. So if you have, for example, a large project, one team might be responsible of creating templates for pipelines that other people use. And they might own the repository which holds those templates. Let's take a closer look at the template structure in YAML. Let's hope this is visible on the stream as well. Basically, here we have a template caller. So basically we just say template is template/content.yaml. So this is location relational to the caller, so in the same folder in your repository. And then we just give in some parameters here to that template. A project name, a VM image, build configuration. This can be whatever you want, whatever you need to do. Then the content of the template itself, we take in the parameters, we can specify default values for them, and then we have a stage here which uses those parameters in this display name, for example. The rest of this is just a normal .NET build. So Nothing really special there. We also get the capability to extend a template. So this allows us to create kind of skeleton templates that other people can use very easily. So first of all, here we have parameters. So we take in a type of step list in, and like it says, this is a list of steps to be completed in your pipeline. Then we run some of our own code, which is kind of hard-coded to the template file. Let's say that we want to run some scans on our code, for example. Then we loop through the step list and have different kind of rules on what can actually be run via this template. So in this case, we have an example of if the key of the step list is not script, we run it. And if it is script, we recheck the whole pipeline because we don't want to allow anyone to use the script task. And then after this, we can run whatever code we want after it again. And it looks like this when we call the pipeline. So we use the extends keyword. We again specify a template. And then we give in parameters. And this is the step list that we were talking about. And both of these bash scripts go through, but then this last one, it has key of script. It will not work. So the pipeline will fail. The same thing can be done with variables as well. So basically, we have a common variables file. We specify some default variables for ourselves. In this case, a project name, VM image build configuration, and also notify stakeholders, which has a value of false. But we can check that if our source branch, in this case, is a release branch. Well, we can say that build configuration is now release and notify stakeholders is true. So when we actually run a pipeline, we can use the template here in our variables. And then we can say that if variables notify stakeholders is true, we have a stage that, let's say, handles emails, sends emails to the stakeholders that, hey, a new build is completed. Then we have an example of using a pipeline from another repository. So as you can see here, we have the repositories as resources. So we specify a repository. This is kind of the identifier for the repo later on in the pipeline. We specify the type. So Git means Azure repos in this case, but there's also GitHub and BitHub bucket integrations available. We can set a name. So in this case, it is in the tooling project in our Azure DevOps organization, and the name of the repository there is build templates. And then we can also specify that from which branch is this taken, this template. And it's taken from master by default, but you can specify whatever you want here. Master is probably the one that you will be using in any case. Then in our jobs, we can just say that in build/common.yaml, in this part, in our templates repository specified here, there's a template that we need to run. Then, of course, more things can run in parallel, as I kind of was foreshadowing earlier. So classic mode only allows for the stage level parallelization. YAML allows you to do dependency graphs for real, so you can do whatever you want with jobs as well. So in this sense, you also save a lot of time when working with YAML. You of course still need to have that many VMs that you want to have parallelizing your tasks. So coming back to our problems, we no longer have repeated work with template structuring. Timing changes is also not very hard any longer because basically the logic moves with your branches or with the code itself. We get Git version control and branching, so we basically can do our own tests in our own branches and then merge to master later on. And we get the parallelization benefits. And lastly, pull request process, so somebody can approve our changes. And we have control of our application this way too. So then we should work with YAML a bit. I have found it to be the best way to start by using the Azure DevOps portal. So let's take a look at that first. The good thing with the portal here is that on the top right corner, you have the Show Assistant button. So if you have been working with Azure DevOps earlier with the classical pipelines, you can use the same tool there. So you can just write in whatever you want, which kind of means that you don't need to look at the documentation so much. You already know what the parameters are that you need to give in, and you can just fill them in here. And when you click Add, you get the full pipeline task ready. And if you click the Settings button here, you can edit it later on as well. So this kind of saves you a lot of time and gets you familiar with the actual process of working with YAML. Once you are a bit more experienced with YAML in general, you might want to change to the Azure VS Code extension. As you can see here, you get some IntelliSense. This same thing is really available in the portal as well, but I like to work in VS Code myself. But I still use the portal at sometimes if I don't want to look at the documentation and figure out what is the parameter that I need to give in. The good thing here with VS Code is that in the portal, you can only kind of edit your main pipeline. If you're calling some other template in your pipeline, that isn't visible in the portal unless you add it as a separate pipeline entity. But in VS Code, you can of course edit all the files at the same time. And if you have some build pipelines in the classic before, you have this View YAML button at the top right corner, and you get the tasks individually or for the whole job that you can just copy paste. And here at the top, visible now, you see that there is an unidentified variable. So it kind of tells you what is missing from the copy as well, so you know what to fix. And this, I think, is the best way to start. So converting your old build pipelines to YAML, you already know the processes there. What do they do? So you can just focus on learning the YAML language. Then play around in the portal in general. Get the VS Code extension. Then read the documentation, of course. You can search GitHub quite easily, as the files are often named just azure/pipelines.yaml. You can utilize templates or create snippets for yourself. At least I know that there are some tasks that I want to be doing often. I have a snippet for that. So it kind of saves you time from copy pasting, but that's also a way forward as well. So I have some demos for you guys still. So first of all, we have a YAML pipeline demo, which goes through some of these steps. So template structuring, more of that. Some variable group stuff, how to utilize them. Then pipelines as resources. Utilizing runtime parameters. Deployment jobs, which are kind of these specialized job types to handle a life cycle of a deployment. Then how do we actually add this pipeline in the portal and running it. And then the second demo I have is a pipeline decorator demo. And the pipeline decorator allows you to add custom logic to every build in the pipeline, or every build pipeline in your organization, for example. So let's begin with the YAML pipeline demo first. Okay, so here we go. So here is a release flow for 2 environments. There are a lot of comments, but we'll go through some of them. First of all, we set a trigger to none. As this is a release pipeline, we don't really need to get anything from the repository, as we just get artifacts in. Then we specify a pipeline as a resource. So this is basically our build pipeline. We have this identifier for it, which we will use in the later tasks. And this source is kind of the display name of the pipeline in Azure DevOps portal. We set it to trigger on branches, master, and release. So anything that has release in the beginning will trigger this, and also master. So this kind of triggers when this pipeline finishes on these branches. Then we set up some variables, nothing special really there. And then we have a couple of stages. These ones are the more important ones, but here's just an example on how to download some artifacts if you need to do them. So this is a short way of doing it. So basically we have checkout none, so we don't need to take anything from the pipe or the Git repository, and then we just use the download keyword for build all. So it downloads the newest packages, in this case from the build all pipeline. Then we have 2 calls to our template. So this is release template.yaml, which has all of our deployment logic in it. We give in an environment and also depends on. These are the more important ones here. And other ones are pointers to these variables that we were giving in earlier. What's inside the release template YAML then? I have a clipped version of it here. So we take in parameters, we specify a stage name, display name, and also here we can use a variable group from Azure DevOps. So basically you can create a group of variables, and this is how you can point to it with the /group here. And I just want a variable group that is named like dev variables, for example. Then we have some jobs here, and these are the deployment jobs that I was talking about. So the idea here is that we have a life cycle of the deployment. There's a kind of different stages and strategies how this can work. And there are a couple types of deployment jobs in general. First of all, the important thing here is that we specify an environment. So an environment is something that is visible in the Azure DevOps portal later on, and this kind of allows you to specify who gets to do approvals on deployments to this environment. So if we hop onto the Azure DevOps portal quickly, here's the environment. So we can see that we have production and development for myself here. And you can go here to approvals and checks basically have approvals of people, or then invoking Azure functions, monitoring query alerts, or so on. And that is how you do approvals in YAML. Then we get to the strategy part. So there are a couple of ones of these. So the most basic one is run once. You just run everything once in your logic. Then you have a rolling, which is for VMs. So update 10 VMs, then update 10 more, and so on. And then for Kubernetes, we have a canary deployment possibility. So let's say 10% of our pods run the new version of this container. Then we have the different stages. A pre-deploy stage, run some scripts before deploying, then the actual deployment, then route traffic, which means that, well, as it says, you can route traffic to the new deployment. Post-route traffic, let's run some tests to the new deployment this way. And then we have the on failure and on success steps. And as an example here, we have a cleaning resource group deployment history. Then we deploy the ARM, and then on failure, let's do some rollbacking or retry. Just a simple example on how that works. Of course, you need to create your step logic yourself. And then we just have backend and front-end deployment here. And here you can see that both of these depend on deploy ARM step. And this means that both of these run in parallel after the ARM has been deployed. Then, when we try to run this in the portal, I'm actually missing a run button for some reason. Let's go to edit. So here, we could say that from which branch does this actually come from, but nothing else. We can't specify what the packages are that we want to use or so on. So this just uses the newest packages available. If we take a look at the classic pipelines, then you still have this selection here, which package to use. So this is probably something that you might want to implement in YAML as well. And how to do that is basically by hand using runtime parameters. So this is a separate pipeline. I specify parameters first. I can set names for them. So artifact branch and build ID and default values. And then in my download artifacts tasks, I can set that what is the build ID, do something with it. And what is the artifact branch, do something with that too. So if it is just the default value, use the default value. And if not, use the actual value that is given in. I have a blog on this, so I won't go too much further on this part here. But the idea with this and with the download tasks and deployment jobs is that deployment jobs have an automatic download of these artifacts. But if you want to use this logic, you will need to add the download pipeline artifact task to the download deployment job yourself. And it ends up being quite a lot of boilerplate code. So it's a bit ugly in that way. But as I have the artifact selection here, I can set that run pipeline. And here I can set the artifact branch now and the artifact build ID. Let's delete this quickly. And if I had a new pipeline, I'd go to new pipeline button here, adding it from Azure DevOps, in this case, from my YAML control repository. And then I could set here, I could set one of these kind of starter pipelines, or existing Azure pipeline from YAML file. So here I have a master branch, and then I can just set what do I want to add here. So if I wanted to do the artifact selection again, now I have it, and I could save it here. Pretty simple. Then my next demo was to be the decorator demo. So basically, a decorator is just an extension, a private extension to your Azure DevOps organization. And what this means is that you need to create your own extension. And here is kind of what my extension looks like, at least the manifest file. So basically here is just the important part. So this is my ID, this is my decorator. It is a type of pipeline decorator. The target is a post job task in an agent job. There are a couple of different ones of these. And my template is just the decorator YAML, which is also included in the package. And what I just do in this decorator is just one step. If a variable is set to true, I run some PowerShell. And how we can test this is via our pipelines. So if we edit this pipeline, we can see that there is just one hello world PowerShell here. But when we run the pipeline itself, let's see if this one actually worked or not. We see that as our stuff completed, we get a reward from the decorator. So we can enter our cat, and we also get a cat GIF link here, which apparently does not work at the moment. Too bad. But what you could use this for is, for example, using a static code scanner on all your repositories, or other things that you might want to run without user interaction on all of your pipelines. And for this pipeline specifically, I did have a variable set here in pipeline variables that cat GIF is true. Quite simple, and there is a tutorial from Microsoft to do this. Yeah, there are still some cons with YAML, but I think it's getting better all the time. The tooling does still need some work, especially the if clauses. It's kind of unclear where can you use them and where can you not. And they might show some squiggly lines even though they work correctly. So the language detection in the tooling is a bit messy at times. Also, there is no great way to locally test your pipelines, so you basically need to commit and go to the portal and see if it works or not. There is a REST API that you can check locally, basically to send your pipeline there and see if your syntax is correct, but that's about it. And it's kind of hard to use without third-party PowerShell, for example. Then not everything is supported yet out of the box. I think this slide is a bit old. So deployment gates, for example, are now supported as well. But as you can call functions, you probably can build something yourself if you really need to. So these are very extensible in any case. So, but if you have some needs, you might reach out to the Azure DevOps team and ask when are these coming from. And yeah, something you take for granted in Classic, like the artifact selection, might be a bit tougher to implement in YAML. The documentation is not yet all there, especially for separate kind of individual tasks that you will be using. So the parameter descriptions are all over the place and so on. So that's why the portal tooling is very helpful. And the learning curve, of course, is there. But once you get past the first hump, you actually get going very quickly after that. So some takeaways from the presentation. First of all, YAML is the way forward in Azure DevOps, and I think you should use it. You should also take a look at the templating when possible, and evaluate the need for a centralized repository in your company. You should, of course, parallelize also everything, and, well, you save a lot of time with that. And then you should utilize the deployment jobs and keep an eye out for further development on those. And of course, try out the VS Code extension. Lastly, some resources and links. So the official documentation, of course. Then Azure DevOps blog, they have patch notes of every sprint. So those are posted there, and you can get a lot more information behind the scenes also from that resource. Not all of that will end up in the documentation, but it might have some examples on how to use some new feature. Then there's .NET Arcade. So the .NET Core team is using this as their kind of centralized repository, and it has some very complicated examples that you might want to look at. So if you don't know how something is done, they might have done it before, so check it out. And then, of course, my blog. I try to write a blog post on pretty much all of the more complicated or easy stuff there. And these slides can be found in this location. And while this slide is here, I will take a look at the YouTube chat to see if I have any questions here. Or if you have any questions, feel free to write them there now. I will be here for a couple of more minutes here. Okay, it seems that my questions or the information from the YouTube chat just came in when I actually wrote in something. So first question for me is that, is there any difference between Azure Pipelines and GitHub Actions? And well, there are differences. They use most of the same backends, and in the future, they will probably be going more closer together. So if you learn Azure DevOps pipelines, it is quite easy to transfer those to GitHub Actions, or at least transfer your knowledge. They use very much the same logic behind them. Yeah, and when you deploy front-end and back-end separately, the site might not work in the end of the server. How do we handle that? Well, that is very dependent on your kind of specific situation. But what I would probably do is that I would use some of these. Let me show you. So we have the environments here. So you could do here in the approvals and checks. You could, for example, invoke an Azure function, or then have a Azure monitor alert, which kind of tells you that the website doesn't work. And then in that case, you would catch the issue of it not working at that point already. Or in the deployment jobs, you could have kind of on failure, on success steps where you add your own logic on what you would do when that fails. And then there was a question on VS Code YAML extension. Let me actually check it out. There's the official YAML extension. So let's see. Yeah, it's just called Azure Pipelines. This is it. And what you need to do also is set the language here to Azure Pipelines, so you get the right stuff here. But as you can see, the if clauses, they are showing some failures here, so it's not yet there. And then how do you build DevSecOps? Well, that's a bit general question. I would say that you could at least have some template that you extend that has your kind of security steps, and then tell your teams that use this, give in a step list, and then your kind of security steps run right there on every build. And then the last question, is there a way to safeguard pipeline tasks from running from other than master builds? That is a good question. I currently don't have an answer for you for that, but I suppose what you could at least do is that you only use kind of the pipeline triggering here and specify which branches trigger it. And then from Azure DevOps side, you set the permissions so that, let's say, no one can run it by hand or even necessarily have the rights to see it. So that's at least one way to do it. Let's see if I update the chat once more if I have new questions. No. All right. Hey, thanks for everyone for joining. You still can get the slides from this location. And what else? Well, I will be streaming another session in, let's say, in an hour, and it's about developing on Data Factory and Databricks. Most of it is Data Factory stuff, but if you are interested in that, check back in to the channel then. Thanks everyone, see you around.